Hello, good evening, students.
Good evening, ma'am.
Yes, very good evening to everyone. Yes, okay. So today we are going to start with the next chapter. Okay, so this is a chapter from organic chemistry, that is alcohol, phenols, and ethers. Okay, so already we have discussed this in our ACE classes. Okay, what are alcohols, what are phenols, what are ethers. Okay, and we have studied the detail everything. Okay, the preparations and all. Right. So everything we have studied in detail, the preparation, physical property, chemical property, right? So we are going to start here with the uh, MCQs. Okay. So here in this sessions, we are going to deal with the MCQs. We are going to see the questions. Okay. What type of questions are asked from this particular chapter? Okay. That is alcohol, phenols, and ether. So basically, what are alcohols? So alcohols are the organic compounds. Okay. Which is having a functional group ROH. Right. ROH. So here the R is a aromatic ring, or it can be your any aliphatic compound, right? Then what are phenols? Phenols are what? They are also organic compound. Okay. So here in alcohols, okay, ROH, for example, I'll give you ethyl alcohol, right? CH3, CH2, OH, right? So you have what? Your R will be your substituted what? Hydrocarbon, right? And when you see phenol, so phenols are what? Phenol is also having ROH, but your R will be a aromatic compound. Okay, one benzene ring will be there. So two benzene ring, if you attach to OH, so it is phenol, right? What are ethers? Ethers are also organic compound, which is having the functional group ROR dash, right? ROR dash. So your R can be a alkyl group or it can be a aryl group. I hope you know what is a alkyl group, what is a aryl group. Okay, so just I gave you a basic idea. Okay, what are the functional groups of how we represent alcohol, phenols, and ethers. Okay, so let us start with the questions now. Okay, so this is our first question. I hope the screen is visible. Okay, and my voice is
Yes,
audible. So
ma'am.
yes. So let us start. So this is the first question. Anisole can be prepared by the action of methyl iodide on sodium phenate. The reaction is called. Okay, one more time I'll repeat. Anisole can be prepared by the action of methyl iodide on sodium phenate. The reaction is called A. Fittig reaction, B. Itard reaction, C. Woods reaction, and D. Williamson reaction. Okay. So what is anisole? Yes, students. What is anisole? So yes, what is the answer? Try. Okay. So anisole is what? Okay, so this compound that is with OCH3 with methoxy group. Okay. Yes, Sri Varuni has answered benzene ring with OCH3. Yes. Okay, so there are many answers which I've got. Lubna has answered as D. Sri Varuni has answered as D. JNV Raichur has answered as D. Preeti has answered as C. Amulya C. Avinash has answered as C. Asma has answered as C. Okay. So let us see the answer. Okay. So this is a compound which has to be prepared. That is a benzene ring with a methoxy group. Okay. Which is called as what? Which is called as a anisole. Okay, so how this compound can be prepared? Okay, so by the action of methyl iodide. So let us write methyl iodide plus sodium phenate. Okay, what is a sodium phenate? So this is a sodium phenate, that is ONA. Okay, that is ONA. So this is a sodium salt, or you called it as what? You called it as sodium phenoxide, right? So this is methyl iodide. So methyl iodide, when you react it with what? Sodium phenate, or you call it as sodium phenoxide. Okay, and what you get? You get a anisole. Okay, you get a anisole. So how you get this anisole? So this is what? So OCH3. So what will happen? Your just let me take this color. Okay, so I will get combined with your Na. Okay, see here, if I write it ONA plus, okay, just to show you how it gets combined. Okay, so it is what? CH3I, right? So your CH3 will get attached here and your OCH3. Okay, so this gets combined. So how it will be? So it will be ONA O minus Na plus. Okay, so it will be how? So just see the combination, how it gets combined. So CH3I, right? So this will get combined. CH3 will get combined with O and your Na plus. Okay, so this is the compound which is formed. So which is this reaction? Yes, so the reaction mechanism. Okay, so this is what? It is a simple what? What is formed here? Here, so this is one OCH3. So is it resembling like a ether, right? Is it resembling like a ether? ROR dash, yes. So which is the reaction? Here it is a Williamson reaction. Okay, it is what? It is a Williamson's reaction, because what we have prepared here, we have prepared a ether. Okay, we have prepared what? We have prepared a ether. So what is our answer? It is a Williamson ether synthesis. Okay, so when methyl iodide, it reacts with your sodium phenoxide, what we are getting? We are getting a ROR dash compound, right? Your one R is your methyl group and another R dash is your benzene ring. Okay, so this is what? It is a ether synthesis. We have done a ether synthesis. So what is our answer? Our answer is D. Okay, so the students who have answered as D, Lubna and Shri Varuni and JNV Raichur. Yes, correct. Your answer is correct. So D is the correct answer. Okay, we are doing a Williamson ether synthesis. Okay, fine. Let us go for the next one. Catalytic dehydrogenation of a primary alcohol gives a catalytic dehydrogenation of a primary alcohol gives a ketone, B ester, C secondary alcohol, and D aldehyde. So catalytic dehydrogenation of a primary alcohol. So what we are doing? We are taking a primary alcohol. Okay, we are taking a primary alcohol and we are doing catalytic dehydrogenation. Dehydrogenation means what? Dehydrogenation means removal of hydrogen. Okay, removal of hydrogen. Dehydrogenation. D means removal. Okay, and hydrogenation means addition. So here what we are doing? We are removing the hydrogen from alcohol. So we need a dehydrogenating agent. So we will take what? We will take copper. Okay, we are taking copper at 300 degrees Celsius. So alcohol, okay, and we are reacting it with copper. So what we are going to get? We are going to get, when we remove this two hydrogen, okay, remove this two hydrogen, what you will get? You are going to get RCHO, right, plus H2. So what is this? This is a aldehyde. So what we got? We have got a aldehyde. So catalytic dehydrogenation of a primary alcohol, it gives you what? It gives you a aldehyde. So D is the answer. Okay, D is the answer. So let me see who all have answered as D. So yes, Asma has answered, Shri Varuni has answered, Amulya has answered, Dupna has answered. Okay, very good. Preeti has answered. Yes, Raichur College has answered. Very good. Okay, so yes. So D is the answer. So when we do dehydrogenation, that is, we are removing the hydrogens, we get what? We get a aldehyde. Okay, we are getting a aldehyde. Okay, so let us go for the next one. Among the following, which is least acidic? Among the following, which is least acidic? A. Paranitrophenol. B. Parachlorophenol. C. Phenol. And D. This is orthocresol. Okay, so this is orthocresol. So among the following, which is least acidic? Paranitrophenol, parachlorophenol, phenol, and D. Orthocresol. Okay. JNB Raichura has answered as D. Preeti has answered as B. Sri Varuni has answered as D. Amulya has answered as B. Asma has answered as B. Okay. Fine. So let us see. Ulubna has answered as B. So what is the answer for third one? So here, among the following, which is least acidic? Okay, so let me write first the structures. Okay, let me write the structures. So paranitrophenol means what? This is a nitrophenol. Okay, this is a nitrophenol. Sorry, let me write phenol first. Okay, and at para position you have a nitro group. So this is what? This is a para nitrophenol, right? At with respect to OH group, this is a para position. Okay, so at para we have a nitro group, so this is a para nitrophenol. Okay, then we have para chlorophenol. So again same, let us write a phenol group. Okay, and then at para position you have a chlorine. Okay, then you have a phenol. Next you have what? Phenol. Then you have a orthocresol. Okay, next you have what? Orthocresol. So phenol, and what is the substituent? It is a CH3 group. Okay, at ortho position with respect to OH. So this is a what? This is a orthocresol. This is phenol. Okay, and this is a phenol. That is orthochlorophenol, and this is paranitrophenol. Paranitrophenol. Okay. Now, so what there was, which is least acidic. Okay. Now, when we are talking about the acidic character, so whenever, so there is, we have studied about the electron withdrawing groups and electron releasing groups, right? In the chapter of alcohol. So very important concept it is. Okay, based on that question is also asked. So what is said there? Yes, so whenever you have a electron withdrawing group, right? Whenever you have electron withdrawing groups. Now, which are the electron withdrawing groups? Now here, which are the electron withdrawing group? Like nitro group, okay, like the chloro group. So these are the electron withdrawing group. So what it will do, the electron withdrawing group, they will decrease the electron density. Withdrawing means what? They will pull the electron towards themselves, right? So electron withdrawing groups means what? Whenever electron withdrawing groups are there, they will pull the electron towards themselves. Okay. So what will happen? Yes. So there will be increase in the acidic character because the electron density is getting decreased. Right, as you're pulling the electron towards itself, so what is happening? There is a decrease in electron density. So because of which the acidity, okay, acidic character will increase. Okay, and wherever you have electron donating groups, okay, whenever you have donating groups, now which are the electron donating groups? Like your methyl group. Okay, like your methyl groups. Now what they will do? They will give electrons. Okay, they will give electrons. So when they are giving electrons, what will happen to the electron density? It will increase. Okay, electron density will increase and acidic character will decrease. Okay, acidity will decrease. Right? Right? Yes? Okay. So now, which is least acidic then? Which is least acidic here? So when we see the least acidity, so nitrophenol is there. So as compared to nitro and chloro, this is more acidic. Okay, so this is more as compared to chloro. Then after chloro, now here at phenol, there is no electron withdrawing or electron releasing group. So this is neutral. Okay, then again, when we see ortho, so what will happen? Electron density will increase and acidity will decrease. Okay, so which is least acidic? It is our orthocresol. So D. Yes. So whoever has answered as D, the answer is correct. Okay. Yes. Baby Lubna. Okay. So Shri Varuni. Yes. Okay. JNV Raichur. Yes. Very good. Okay. So yes, D is the correct answer. So remember the acidity concept. Okay. With respect to your alcohols, phenols, right? So please study the acidity concept, that is the effect of electron withdrawing group and effect of this electron releasing group. Okay, so study that, very important concept with respect to theory also. So next is fourth question. The best method for the conversion of an alcohol into an alkyl chloride is by treating the alcohol with. So what we need to do, we have to convert an alcohol into a alkyl chloride. So how we are going to do this method? How we are going to do this reaction of converting the primary alcohol, that is your alcohol, into the alkyl chloride. Alkyl chloride. How we are going to do? So which is the best method? So there are four options. A, PCl5, that is penta, phosphorus pentachloride. B, thionyl chloride in the presence of pyridine. C, dry hydrochloric acid in the presence of anhydrous ZnCl2, that is zinc chloride. And D is PCl3, that is your phosphorus trichloride. Okay, phosphorus trichloride. So which is the best method? Okay. So here are some answers. JNV Raichur has answered as D. Preeti has answered as B. Shri Varuni has answered as D. Amulya, Asma has answered as B. Amulya and Asma. Then Lubna and Baby has answered as D. Asma. Okay. These are the answers. Over. Okay. I have missed some. Srujana and Sanjana have answered as C. Niharika has answered as B. Lubna has answered as D. Anil has answered as B. Okay, fine. So let us see. Okay. So what is the answer? So when we are doing the conversion, okay, when we are doing the conversion, when we are doing the conversion, that is from alcohol to an alkyl chloride. Okay, so how we are going to do that? So that is a best method. When we have studied the preparation of alcohol, the best method to prepare alkyl chlorides from alcohol is by treating it with thionyl chloride. Why? Alcohol, okay, when you treat it with thionyl chloride, so this is the best method, because in the presence of pyridine, okay, in the presence of pyridine, it gives you alkyl chloride, okay, plus sulfur dioxide plus HCl. Why this method is best method? Because the byproducts obtained are gases. Okay, the byproduct obtained are gases and they will escape out, right? They will escape out. So the product yield found will be more, right? So this is the best method for the conversion of alcohol into alkyl chloride. So this is B answer. Okay, so who all have answered as B? So this is the best method, okay, for preparing your alkyl chloride. Okay. Why? If they ask you why, what is the reason? Because the byproducts obtained are what? They are the gases. And gases, they will easily escape out. Right? They will easily escape out, okay, from the reaction mixture. So this is the best method. So option number. So option number B. Okay, so option number B. So whoever have answered as option number B, yes, it is the right answer. Okay, let us go for the next one. Lucas test is associated with. Lucas test is associated with A, phenol, B, carboxylic acid, C alcohols and the aldehydes. So Lucas test is associated with A phenols, B carboxylic acid, C alcohol, and D aldehyde. Lucas test is also a very important test. It is a distinguishing test. Okay. Lucas test. What is a Lucas reagent? Lucas reagent. Yes. Concentrated HCl. Yes, Niharika has answered as B. Srujana and Sanjana have answered as A. Preeti has answered as B. Asma Kencha has answered as B. Yes, baby has answered correct. It is what? Lucas reagent. Okay, what is the Lucas reagent? Lucas reagent is concentrated HCl and anhydrous. Okay, and anhydrous zinc chloride. So remember this. Remember this. Okay. So option number, yes, and Lucas test is famous for alcohols. Okay. So option number C is the answer. Option number C. So who all have answered as option number C? Okay, it is a correct answer. Yes, baby has answered, Lubna has answered. Okay. Yes, option number C is the correct answer. So Lucas test, it is associated with what? It is a distinguishing test. Okay, why we are doing distinguishing test? Because in alcohols we have three types: primary alcohol, secondary alcohol, and tertiary alcohol. So if the given alcohol, we don't know what type of alcohol is present. Okay, so by doing Lucas test, we can distinguish whether it is a primary alcohol, secondary, or tertiary. Okay, so in primary, we do not get the PPT, right? Okay, in primary, we do not get the PPT, right? And in secondary, what will happen? You get a PPT, okay, but after some time, right? After some time, you get a PPT. And in tertiary, you get PPT immediately. Okay, immediately. So this is the distinguishing test. In primary, no PPT. In secondary, you get a PPT after 5 minutes, maybe, or 2 minutes, 2 to 5 minutes. And tertiary, you get immediately. Okay, so this is the distinguishing test. You have to take the given alcohol, okay, and add this Lucas reagent. So you will see this particular uh, test. Okay, fine. So option number C, please note it down. Option number C is the answer. I hope your doubts are clear. Okay, so what is Lucas test? It is a distinguishing test between the primary, secondary, and tertiary alcohol. Okay, let us go for the next one. 1 mole of an organic compound A with the formula C3H8O reacts completely with 2 moles of HI to form X and Y. When Y is boiled with the aqueous alkali, it forms Z. Z answers the iodoform test. The compound A is, so which is the compound A? A propanol, B propan1-ol, C ethoxyethane, and D methoxyethane. Okay, so let us see stepwise. Okay, let us see the stepwise reaction. So if A, what they have asked, 1 mole of organic compound A. Okay, and this compound is having C3H8O. Okay, it reacts with what? This is a 1 mole. 1 mole, it reacts with 2 moles of HI. Okay, 2 moles of HI, that is your hydrogen iodide. Okay, to form, and what it forms compound X and Y. Okay, now when Y is boiled with aqueous alkali, okay, we have a alkali, with that it is boiled, so it forms Z. Okay, and Z is answering the iodoform test. Z is answering the iodoform test. So they have asked, what is A? What is A? So this is the question. Now here, Okay, so what is A? So let us see. O is there. Shall it be a ether? Yes. Can it be a ether? Because iodoform test, okay, it is shown by what? Iodoform tests are mostly shown by alcohols. Right. Now here, if A reacts with your HI. Now your A can be, okay, if your A can be, so if it is CH, so if I take a ether, so one will be a methyl group, okay, then we are left with what? C2 carbon and H 5, 6, 7, 8, 5 carbon. Okay, so if it is a ether, okay, if it is a ether, this is your what? This is a methoxyethane. This is what? Methoxy. This is your ethyl methyl ether, right? This is your ethyl methyl ether. This is a ethyl methyl ether. Now this ethyl methyl ether, if you treat it with HI, okay, excess of HI, what you will get? One product with your methyl, your iodide will combine, and your this another, because there are 2 moles. So again one ethyl, okay, and plus water, okay, again water. So this is the compound. So this can be your X, this can be your Y. Now if I take Y, so what is Y? Your ethyl iodide. Okay, ethyl iodide. So if I treat it with some aqueous alkali, so which alkali I'll take? I'll take a aqueous NaOH. Okay, I'll take aqueous NaOH. So okay, so what will happen? Your iodide will be what? Exchanged, or it will be substituted with what? Which nucleophile? OH. Okay, so you will get ethyl alcohol. What you will get? You will get a ethyl alcohol. Right. Now this ethyl alcohol. So ethyl alcohol, it will answer the this what? Ethyl alcohol will answer the test. Right. So here, what is the answer? So it is methoxyethane. Okay, D. Yes, D is the answer. So who all have answered as D? Amulya has answered as D. Asma has answered as D. Preeti has answered. Lubna has answered. Okay. Yes. So D is the answer. Okay. Yes. So like this. What is there? Ether is there. So ether. So they have given the formula. Okay. So that is reacting with what? 2 moles of HI. So when it reacts with HI, you get substituted iodides, right? You get a methyl iodide, you get a ethyl iodide. So that is X and Y. Then what they have said, Y is reacting with aqueous alkali. You get a alcohol. Okay. And this alcohol will answer the iodoform test. So which is a compound? It is a methoxyethane. So option number D is the answer. Okay. Let us go for the next one. Okay. An organic, uh, uh, an oxygen containing organic compound upon oxidation forms a carboxylic acid. Okay. As the only organic compound with its molecular mass higher by 14 units. The organic compound is an aldehyde, a primary alcohol, a secondary alcohol, and a ketone. So there is a organic compound, and that organic compound is containing what? It is containing a oxygen. Okay, and that organic compound, when you do oxidation, what is oxidation? Addition of oxygen. Right, addition of oxygen is called as what? It is called as oxidation. Right. So after doing oxidation, you are getting a carboxylic acid. Okay, you are getting a carboxylic acid. Okay, now this carboxylic acid, carboxylic acid as the only organic product. Okay, and by doing oxidation, there is an increase in mass, molecular mass by 14 units. Okay, by 14 units, the molecular mass is increased. Now, what is the organic compound they have asked? Now, the difference in the mass is what? It is the 14 units. Okay, it is between 14 units. Okay, now what is the compound? So carboxylic acid is what? Carboxylic acid is COH. Now carbon is what? 12 plus oxygen is 16 plus 16 plus hydrogen. Okay, hydrogen is 1. So here what you can see, carboxylic acid. Okay. Now if you take the simplest, okay, if you take a simplest alcohol, this your simplest alcohol, that is your ethyl alcohol. Okay. If you take ethyl alcohol and if you do the oxidation, okay, if you do oxidation, that is, so whenever you take a alcohol and you do oxidation, alcohols are converted into carboxylic acid. Okay, what is happening? Alcohol is converted into carboxylic acid. Now here we have taken starting compound. Okay, we will see with ethyl alcohol. Okay, we are taking ethyl alcohol. Now ethyl alcohol, when we do oxidation, what we are going to get? We are going to get CH3, CH, COOH. Okay, so there is a, what is happening here? Addition of oxygen and remole of hydrogen. Now count the molecular formula. Let us see. Let us see. So carbon is 12. So 12 into 2. 12 into 2. Yes. Plus oxygen is 16 into 2. Plus hydrogen is 1 into 4. So calculate 12 2s are 24 plus 2 6 are 12, 2 1s are 2, 332 plus 4. 60 grams. Okay, this is 60 grams, and your here you calculate carbon is 2, hydrogens are 6, and oxygen, right? Carbon 12 into 2 plus 6 plus 16, 24, 6 and 16, 46. So difference between this is 40. Okay, yes. So it is what you have got. So which is the compound? It is a primary this alcohol. So option number B. Okay, so it is a primary alcohol. So whenever you have a okay, what they have said, there is an organic compound which is having oxygen. Okay, and when we are doing oxidation, you are getting carboxylic acid. So whenever you have a primary alcohol, when you do oxidation, you get a carboxylic acid. So we have taken the simplest or alcohol, that is your ethyl alcohol. Okay, it is forming what? It is forming a acetic acid. So we have calculated the molecular mass. We can see the difference between the molecular mass is 14 grams. Okay, that is so it is what? It is a ethyl alcohol. Yes. So Lubna has answered as B. Yes. Okay. Okay, so here once more I'll repeat. Now here what they have asked, what is the question? And organic compound is there, and that organic compound is containing oxygen. When you do oxidation on that organic compound, you are going to get a carboxylic acid. Okay, now remember that whenever you have a primary alcohol, whenever you have a primary alcohol, and when you do oxidation, what is happening? You are going to get what? You are going to get a this one carbon extra compound. Okay, you are going to get a compound with a higher molecular mass. So here you can see there is no carbon and oxygen. So there is there can be an increase in weight here, right? So whenever you have a primary alcohol, so primary alcohol, when you do oxidation, you are going to get a carboxylic acid. So what they have said that the after doing oxidation, there is increase of molecular weight by 14 units. Right. So if I take a simplest, I have tried with simplest alcohol, that is ethyl alcohol. So if ethyl alcohol, if you do oxidation, you are going to get acetic acid. CH3 COOH. Now, when you calculate the molecular mass, this is 60 grams and this was 46 grams, right? So what is the difference between this? 60 minus 46 is 14. So which is the answer? It is a, what is this compound? It is a primary alcohol. What the four options are? Aldehyde, primary alcohol, secondary or ketone. So it is a primary alcohol. So option number B is the answer. Okay. Yes. So who all have answered as B? It is a correct answer. Okay. Understood up to here? Are the questions clear up to here? Any doubts? Any doubts up to here? If you have any doubts, please ask. 7 questions we have seen. Okay, up to 7 questions. Any doubts? Okay, Lubna has no doubts. Others? Fine. Okay, let us continue then. Next question. Phenol. Okay, phenol. Phenol, it forms a tribromo derivative. In the presence of X, it forms a tribromo derivative. What is this X? Okay, phenol. So this is our phenol. So please tell me, phenol, when it presents with the X, it forms a tribromo derivative. Now this is a tribromo derivative. Tribromo means 1, 2, and 3. So at these positions, you have a bromo groups. So this is our tribromo derivative. Now what is that? X. A, bromine in benzene, B, bromine in water, C, potassium bromide solution, D, bromine in carbon tetrachloride at 0 degree Celsius. So phenol, okay, when you react with what? When you react it with, this is a, this, okay, they will ask you in, they'll keep empty spaces in theory also. They'll keep empty spaces and they'll ask you, what is this X, like that. So this, these are some of the important reactions which you have to go through. So if you react this with bromine water, okay, if you react it with bromine water, you are going to get what? You are going to get tribromo derivative. What is the name of this tribromo derivative? It is at, this is the positions. Let me write the positions. So 1, 2, 3, 4, 5, and 6. So it is 2, 4, 6, 2, 4, 6. Then you have 1, 2, and 3. So 2, 4, 6, tribromo. And what is the parent? This compound, it is phenol. So 2,4,6 tribromophenol. So what is the answer? Bromine in water. Okay, bromine in water. So very important reaction. Okay, when we are preparing the tribromo derivative. Lubna has answered as B. Very good. Srivaruni has answered as B. So yes, okay, both your answers are correct. So yes, B is the correct answer. Bromine in water is the correct answer. Okay, let us go for the next one. Identify B and D in the following sequence of reactions. So this is the reaction going on. So you have to find out what is B and D. Okay, what is B and D in the following sequence? A, methanol and bromoethane. B, ethyl hydrogen sulfate and alcoholic KOH. C, ethyl hydrogen sulfate and aqueous KOH. D, ethanol and alcoholic KOH. So what is our this? So ethene is there. Okay, this is our ethene. Okay, now ethene, what is happening with ethene? We are treating it with concentrated H2SO4. Okay, we are treating it with concentrated H2SO4. So what is happening? One of the hydrogen is replaced by what? It is replaced by H plus and HSO4 minus. Okay, when HSO, this will split. So what you are going to get? You are going to get CH3, CH2. Okay, CH3, CH2. Okay, so one hydrogen is added. So CH3 and here CH2 and HSO4. So this is our A. This is our A. Now further, what they have done, they have treated it with water. They have heated with water. Okay, after heating with water, what will happen? This SO4, okay, the SO4 will go and OH will add. So what you're going to get? You're going to get a alcohol. Okay, you're going to get alcohol. So your SO4 will be converted into what? H plus and OH minus. So OH minus. So OH minus will replace this SO4. So what you're going to get? You're going to get the okay, so this is going to replace your OH minus. So CH3, CH2, OH. So this is your B. This is your B. Now this B further it is treated with phosphorus tribromide, right? So what you are going to get? What is your leaving group here? Br. Okay, Br is a good leaving group. So your OH is substituted by CH3, CH2, Br. Okay, CH3, CH2, Br. Now this CH3, that is your ethyl bromide. Okay, you get a ethyl bromide. Now this is C. Now this ethyl bromide, you are going to treat it with what to give you ethene. So if I treated this with alcoholic KOH, okay, if I treat it with alcoholic KOH, which is a good dehydrogenating agent. Alcoholic KOH is what? It is a good hydrogenating agent. So when you treat it with the good dehydrogenating agent like alcoholic KOH, you get a ethene. Okay, you get what? You get a ethene. So your ethyl bromide, okay, ethyl bromide, when you have a alkyl halide, okay, and you want to convert it into ethene, you are going to use the dehydrogenating agent like alcoholic KOH. So which is our answer? What they have asked? B and D. So ethyl, alcohol and alcoholic KOH. Ethanol and alcoholic KOH. So yes, D is the answer. Yes, D is the answer. Yes, D is the answer. Yes, Lubna, Shri Varuni, Baby have answered it correct. Very good. Yes, D is the answer. Okay, fine. Let us go for the next one. The compound which gives turbidity immediately with Lucas reagent at room temperature is. Okay, so we know that what is Lucas reagent? Okay, Lucas reagent, it is what? It is a reagent which consists of concentrated HCl and ZnCl2. Okay. Okay, so what is Lucas reagent? It is concentrated HCl and ZnCl2. So when you react it with primary alcohol, I said what? When you react it with primary alcohol, you don't get any PPT or there is no reaction. When you react it with secondary alcohol, you get a PPT, but after 5 minutes. Okay, you get PPT after 5 minutes. Okay, after 5 minutes. And tertiary alcohol, when you have a tertiary alcohol, you get PPT immediately. Okay, you get PPT immediately. Remember this. Now, so which will give you immediately? Turbidity immediately, it should be a tertiary alcohol. Now, find out which is a tertiary alcohol among this options. A, butane 1-ol, B, butane 2-ol, C, 2-methyl propane 2-ol, and D, 2-methyl propane 1-ol. So you need to know how to write the structures here. Okay, you need to know how to write the structure. So butane, which is the answer? So which is the tertiary alcohol? Here it is a 2-methyl propane 2-ol. Okay, it is a 2-methyl propane 2-ol. 2-methyl propane. So this is a 2-methyl propane 2-ol. So 1, 2, 3. So at 2 position you have a methyl group. Okay, and at 2 position you have a OH group. So this is the tertiary alcohol. So C is the answer. Butane 1-ol is what? It is a primary. This is a secondary, and 2-methyl propane 1-ol. This is also a secondary, right? So answer is C. Understood? Understood? Yes. So our answer is what? Our answer is C. Yes. Shivaruni has answered. Lubna has answered it correct. Yes. Very good. Okay. So yes, C is the correct answer. Fine. Let us go for the next one. Next question. Power alcohol is a mixture of power alcohol is a mixture of A, 80% of petrol plus 20% benzene plus small quantity of ethanol. B, 80% petrol plus 20% ethanol plus small quantity of benzene. C, 80% ethanol plus 20% benzene plus small quantity of petrol. D, 50% petrol plus 50% ethanol plus small quantity of benzene. So remember that what is a power alcohol? So power alcohol, it is a mixture of 80% petrol. Please note it down. Okay, it is a 80% petrol, 20% ethanol. Okay, and small quantity of benzene. Okay, so it is 20% ethanol and 80% petrol. Okay, or that is your gasoline. Okay, and this is called as power alcohol. Where it is used in internal combustion, okay, engines to drive power. So when you need to drive power, okay, in the vehicle, so that time you are making use of this power alcohol. Okay, so when you want power in the vehicles, okay, so that time we use this type of alcohol. So which is the answer? It is B. Okay, it is B. Yes. Okay, fine. The next question. Identify C in the following. Identify C in the following. So this is a reaction. Okay, benzene. Okay, you have a benzene in the presence of this alkyl chloride. Okay, you react it with anhydrous AlCl3 and HCl, you get A. When you react with oxygen in at 130 degrees Celsius, you get B. Okay, further reacting with dilute H2SO4 at 100 degrees Celsius, you get phenol plus C. So they have asked what is this C. They have asked what is this C. Okay. So identify C here. So you have a benzene. You have what? You have a benzene. Okay. You have CH3, CH, CH3, Cl. Okay. So that is 2-chloro or propane. 2-chloropropane. Okay. You have 2-chloropropane. Okay. So here, so what you are going to get in the presence of anhydrous AlCl3. Okay, in the presence of anhydrous AlCl3, what you are going to get? What will happen? So your benzene will be substituted. Okay, you are going to get what? You are going to get a isopropyl alcohol, right? You are going to get a isopropyl benzene. Okay, sorry, isopropyl benzene. Isopropyl benzene. This is what? This is a cumene formation, right? Remember cumene formation? Yes. So this is a cumene formation. So you have isopropyl, okay. So isopropyl benzene, that is a cumene formation. Now this cumene formation, further what we are doing, we are reacting with oxygen. Okay, we are reacting with dioxygen at 130 degrees Celsius. So what will happen? There will be placement of this two oxygen. We are going to get what? Cumene hydrogen hydroperoxide, right? We are going to get what? Cumene hydroperoxide. So that is CH3 and CH3. So this is what? This is cumene hydroperoxide. So this is hydroperoxide. Okay, cumene hydroperoxide. Further, I'm going to treat it with what? Dilute H2SO4. I'm going to treat it with dilute H2SO4 at 100 degrees Celsius. Okay, at 100 degrees Celsius. What I'm going to get? What is the product? Phenol. Okay, remember the synthesis and what is a byproduct? It is a acetone. Okay, it is a acetone. So acetone, what is the name? It is a propanol. Propanol. Okay, it is a propanol. So yes, B is the answer. Okay. So this is the answer. Okay. Okay, so what is the answer? C. Okay, C is the answer. So this is what? This is a preparation of phenol. So this particular preparation where we have studied in the preparation of phenol. Yes, Lubna Shivaruni has answered it correct. So yes, C is the answer. Okay, fine. Last question. Which of the following is strongly acidic? Which of the following is strongly acidic? A. Phenol, B. Orthocresol, C. Paranitrophenol, and D. Paracresol. Yes. Which of the following is strongly acidic? Strongly acidic means what? Which will be strongly acidic? Electron withdrawing group, right? Electron withdrawing group. They will increase the they will decrease the acidic electron density, and thus there will be increase in the acidic strength. So when you write paranitropresol, okay, your paranitrophenol, then will be your phenol, then will be your orthocresol, and then will be your paracresol. Okay. So here, which is most acidic? It is your C. Okay, C is the answer. Yes. So who all have answered as C? Yes, Shivaruni, Baby, and Lubna. Very good. Okay, so C is the correct answer. Okay, fine. So any doubts up to here? Any doubts up to here? So we have seen some 13 questions. Okay. This is a little bigger one. Okay, this will take time, 14th one. So we will see the remaining questions in the next time. Okay, any doubts up to here? Okay, Lubna has no doubts. What about others? Any doubts up to here? If you have any doubts, please, you can ask. Okay. So yes, so in today's session, we have seen 13 questions, okay, based on alcohol, phenols, and ether. So the remaining questions we'll be discussing in the next class. So we have many questions, okay. So what type of questions will be are asked, okay. What type of questions are asked in the CET? So those all questions I have taken here. So different type of questions we will see in the next class. Okay. So yes, thank you. Yes, so I'll end the session here. Okay. So yes, thank you everyone.
Bye, ma'am.
Yes.